Hi, welcome back. We're still on page 20 of the Trig Packet. I just wanted to make sure to take some time to look closer at examples 15 through 18 here, where the directions say, here's an angle given in radians. You notice none of these measures have units on them. They're assumed to be in radians, not degrees. Can you sketch the angle in standard position? Well, know that you've got conversions now. So if you're looking at 7 pi over 6, and if it doesn't just come to you that, oh, I know what quadrant this is going to be in, you could always convert, right? You can multiply by 180 over pi to get the degree measure if that makes you feel better about which quadrant you're landing in. I think you'll get a 210. So for this one, what we can also do, and what I'd like to practice with, is can you divide the pi up into sixths? So basically from 0 to pi, I want to divide this up into 6 parts. So 1 part, 2, 3 pi over 6 is at half pi, that line's already there. 4 pi over 6, 5 pi over 6, and then you're all the way to pi, 6 pi over 6. If you count one more than that, you're here at 7 pi over 6. We get a more accurate picture of where that thing's going to fall. I'll just draw the angle right over it. So standard position, initial side, terminal side, quadrant 3. Let's try 9 pi over 4, and now we're going to count in quarters. So here's 0 to pi. I'd like you to split that up into quarters. So here's 1/4 pi. 2 quarters, 3 quarters, 4 quarters, keep going, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. We're getting really close. Here's 9 pi over 4. So this has actually brought you full circle and around again to 45 degrees, or to where pi over 4 would fall. This would be 9 pi over 4. You can do the same thing in thirds, and this is a high one to count up to. 13 pi over 3, we have a lot of counting to do. Here's 0 to pi. Let's split this into thirds, so 1/3, 2/3, here's 3/3, that's pi, 4/3, 5/3, 6/3, I'm at 2 pi, right? Gotta get up to 13, 7/3, 8, okay, 9/3, 10/3, 11/3, 12/3, I'm up to 4 pi, 13/3. We're back in quadrant 1 again, 13 pi over 3. So wow, that's around again, and then back to the beginning. How about 11 pi over 6, the last one in this row? So we've got to count in sixths. Let's split up our unit circle. We'll go 1 pi over 6, 2 pi over 6, 3 pi over 6. This is not drawn to scale, so half pi. 4 pi over 6, 5 pi over 6, here's 6 pi over 6, we're at pi, 7 pi over 6, 8 pi over 6, 9 pi over 6 is 3 pi over 2, and then 10 pi over 6, here's 11 pi divided by 6. In this one, I mean, in some of these, maybe I could have taken a hint by looking at it for starters. If I was at a full 12 pi over 6, I would have been all the way full circle around to 2 pi. That's 12 pi over 6. So we're just coming back a sixth. And if you're already thinking reference angles, that's going to help us in tomorrow's lesson. 11 pi over 6 has a reference angle of just 30 degrees, or just pi over 6. But I'll leave that for the next time. Last thing I want to do is just a little exercise with the unit circle. We have worked with degrees a lot. So first thing I want to do is go around and fill in the degree measures at the special important angles where we know some exact values. So go quadrantal first. So 0 degrees, 90. We'll say 180, 270. And then if you want to come all the way around, you're back to 360. So this is old news for us, as are these special angles, right? You've got 30 degrees, 45 degrees, and 60 degrees. We've talked about a lot in this unit. Keep going. Add another 60 to that to get 120. Has a reference angle of 60, right? We know these. 135 has a reference angle of 45, and 150. Can we get the reference angles of these three things down in quadrant 3? So 180 add to that 30, you'll get 210, right? 225, 240. And then over in the final quadrant, 270, then you're up to 300 we've worked with a lot, 315, and 330. And the new thing I want to add to this, the exciting part, is we can also do a lot of these same stuff in radians. So I want to put the radian measures just to start to get used to them, start to get them into our heads around these special angles. So start with the quadrantals. So we've talked about 0 radians, no need for any unit, half pi, right? And you have a full pi when you're looking at the unit circle. Then 1/2 pi, 2/2 pi, this is 3/2 pi, 3 pi over 2. And then you're back to 2 pi once you've gone the whole way around. Now go into the special angles. Let's do the ones with 30-degree reference angles. So you have 30 degrees, which is pi over 6. We can confirm that by multiplying this by pi over 180. 45 degrees is going to be pi over 4, a quarter pi. And 60 degrees is double 30 degrees. We've converted this and gotten pi over 3. Check out the ones that they link up with, right? 120 also has a pi over 3 reference angle. 1 pi over 3, this one's 2 pi over 3. And I want to keep going with that. Can we go down 3 pi over 3? I want to go all the way down to 240, which is 4 pi over 3. All these you can confirm with a conversion, right? If you want to either pull out a calculator or do it by hand, you can, but it's kind of cool visually. 1/3, 2/3, 3/3. Now I circled it down here, 4/3. 300 is going to be 5 pi over 3, and then I've made it the full way around. 6 pi over 3 we called 2 pi. Okay, I want to do this a couple times more. Let's try it with the quarter pi reference angle. So here's pi over 4. Right, that's 1/4 pi. Pi over 2 was 2 pi over 4. This one's going to be 3/4 of the way to a full pi. 3 pi over 4. 4 pi over 4, here's 5 pi over 4. We're just counting quarter pies at 225. 6 pi over 4 is this angle, and then 315 degrees is going to be 7/4 pi. 7 pi over 4. And then lastly, let's try the missing angles, the pi over 6 reference angles. So here's pi over 6, right? We already got 2 pi over 6. That's 60 degrees. 3 pi over 6 is 1/2 pi. 4 pi over 6, this one's going to be 5 pi over 6. Not quite to a whole pi. It's got a reference angle you're leaving out of pi over 6. Okay, let's do 210 should be, you have 6 pi over 6. We'll do 7 pi over 6. What am I missing? 8 pi over 6, 9 pi over 6, 10 pi over 6, last one, 11 pi over 6 that we were just working with. And what you'll see into tomorrow's lesson too is a lot of the same stuff we did with degrees we can do with radians. If I ask you for coterminals back with degrees, no problem. I say find me something coterminal with 210, you could add or subtract any integer multiple of 360. Well, same thing here, but I'm going to say in radians, you can add or subtract any integer multiple of, well, what is 360 in radians? We'll say of 2 pi now. We're working with fractions and multiples of pi. And that would work here. For 13 pi over 6, that angle too big for you, subtract 2 pi once, you'll get something that's still positive but coterminal. It'll fall in the same spot. So 13 pi over 6 minus 2 pi is kind of like saying minus 12 pi over 6, leaves you with pi over 6 exactly left over. So you've gone the whole way around the circle and 1 pi over 6 more than that to land in quadrant 1. If you need a negative coterminal angle, just like with degrees and 360s, we can continue subtracting any integer multiple of 2 pi. So minus 2 pi again, right? Minus 12 pi over 6 gives you negative 11 pi over 6. We'll land in the same spot. I'm going to try this one last time. Let's try it with negative 2 pi over 3. If we add 2 pi once, we should get a positive coterminal angle. So adding 2 pi is like adding 6 pi over 3. You get 4 pi over 3. That should fall in the exact same spot. And if I want a negative coterminal angle, just to finish it off, you can subtract 2 pi. So minus 6 pi over 3 gives you negative 8 pi over 3. These are not new concepts. This is just great review for us. We're working in radians instead of degrees. Nice job today, and I'll talk to you later.